Okay, welcome. Happy Sunday. Welcome to multiplying polynomial pre-assessment. We're going to start off by multiplying monomials times binomials. This is a monomial, and we will be multiplying by a binomial by each term. So we have a term here, we have a term here, and we're going to multiply it by this term. So when we distribute, we take this 4 and we multiply it by the 6v plus 4 times the 7. Now, an important thing that we've really pointed out is this positive is attached to the 7, not here. This positive is not this positive. This positive is attached to the 4. That's why this is a positive. So very important for you to keep track of that. So we have 4 times 6v plus 4 times 7. So 4 times 6v is 24v. 4 times 7 is 28. We are distributing a 6k into 5k plus 6k times negative 7. So here's where we see that important. That negative is attached to the 7. That negative will be with the 7, not the 6k. Some students write negative 6k. That's wrong. We're distributing out a positive 6k. So 6k times 5k is 30k squared. 6 times 5 is 30. K times k is k squared minus 42k. 2n squared times 4n plus 2n squared times 8. Coefficients, 2 times 4 is 8. Variables, like bases, we add their exponents, so that's n cubed. Constants, coefficients, 16n squared. Make sure your answers are in standard form. We have 2 times 8n plus 2 times negative 1, 16n minus 2. 8 times 8x plus 8 times negative 4, 64x, negative 32. Now we're distributing a negative 2a times negative 2a minus 2a times 8. So this is our first situation where we see this negative here because it's the coefficient, is that what we're distributing is a negative 2. So we have to have that negative with the 2a. Negative 2 times negative 2 is 4. A times a is a squared. Negative 2 times 8 is negative 16a. Negative 6 times 4p minus 6 times 5. Negative 24p minus 30. And we should be relatively fast at it now. We see how we're going to distribute things and where each of the signs go depending on the 3 terms. 6 times negative 8 is negative 48 x cubed. That's going to be plus 42x squared. This is in standard form. X cubed comes before x squared. Now we have a binomial times a binomial, a little bit different. Binomial times a binomial, we're going to take this first term, we're going to distribute it to the 2 terms in the other binomial, and then we're going to take the second term and we're going to multiply that by the 2 terms in the other binomial. So we call that, I call it a double distribution. Some people call it FOIL, first, outer, inner, last. First would be b times b. Outer would be b times 8. Inner would be 1 times b. And lasts would be 1 times 8. Same thing as double distribution, b times b, b times 8, 1 times b, 1 times 8. B squared plus 8b plus b plus 8. We have like terms here. So after we double distribute, we have to also still check to see if there are any like terms, which there were in this case. And my final answer is b squared plus 9b plus 8. We can't combine these. None of these are like terms. So we're done with our answer. Let's distribute 4r times 6r plus 4r times negative 1 minus 1 times 6r minus 1 times negative 1. 24r squared minus 4r minus 6r plus 1. Like terms here, 24r squared minus 10r plus 1. That's a good one. I like that one. 5n times 2n plus 5n times negative 7 plus 4 times 2n plus 4 times negative 7. 10n squared, not a very good squared, sorry. It's not a good 2. Let's clean that up. Minus 35n plus 8n minus 28. We'll combine these like terms. 10n squared minus 27n minus 28. Yep, that's good. We have 4x times 3x plus 4x times 8 minus 6 times 3x minus 6 times 8. Very important to have all these addition and subtraction signs in here. We have 3 terms that we create because we're distributing, or 3 terms. We have 4 terms that we create because we're distributing 4 times. So of course we're going to have a product, a product, a product, a product, and it's going to be the sum or subtraction of those 4 products. So 12x squared plus 32x minus 18x minus 48. Like terms, 12x squared. What's that going to give us? 14? 14, yep. That's going to be plus 14x because we have more positives than negatives. And there's our answer. All right, these are special. These are special because we call these conjugates. Conjugates are very specific types of binomials. They're identical in their terms, they just have opposite signs on their second. So let's check and see what happens when we distribute. Is it going to change anything? How is that going to affect my solution? So you have n times n plus n times negative 7 plus 7 times n plus 7 times negative 7. N squared minus 7n plus 7n minus 49. So we still have like terms here, but notice what they are. They're opposites of each other. Negative 7n, positive 7n. So my outside and inside terms, my 2 terms here, are going to cancel, leaving me with n squared minus 49. So we have b times b plus b times negative 6 plus 6 times b plus 6 times negative 6. 6 and b are not good to be together because my b's look like my 6's and my 6's look like b's. So make sure you're keeping track of that. That's supposed to look like a 6. That's going to give me b squared minus 6b plus 6b minus 36. My outside and inside cancel, leaving me with b squared minus 36. And when we look at these solutions, notice there's only 2 terms. Every time we multiply conjugates, it always produces 2 terms here. And those 2 terms are subtracting each other. And notice that the 2 terms are perfect squares. We call this the difference of 2 perfect squares. The difference of 2 perfect squares. Now, we don't need to know this in simplifying or multiplying. We will need to recognize that when factoring, when we're going to go in the other direction. We're going to be given this, we're going to factor it to conjugates. So just something to keep in mind as we go. These are called binomial squares. And they're called binomial squares because they're binomials and they're being squared. So the mistake is to distribute. Mistake. Do not do this. Do not distribute the exponent. And what I mean by that is do not distribute this and do not make it m squared plus 9. No. That is a big no. A binomial square means that the base of this exponent, m plus 3, is multiplying by itself 2 times. Whoa. So it looks like this, and if we do the double distribution, we get m times m plus m times 3 plus 3 times m plus 3 times 3. M squared plus 3m plus 3m plus 9. These do not cancel. This time they double. So m squared plus 6m plus 9. And that's the product of a binomial square will always create 3 terms and not 2 terms like that. So let's take a peek at when there's subtraction. A times a plus a times negative 8 minus 8 times a minus 8 times negative 8. So a squared minus 8a minus 8a plus 64. We again have doubled. Our inside and outside are a doubling. So a squared minus 16a plus 64. So now let's look. These, what are the characteristics that these have? Well, notice 3 terms. Binomial squares always produce 3 terms. Our third term is always going to be positive because they're identical. Whether they're both negative or both positive, it's always going to be a product of 2 positives or 2 negatives. So we have 3 terms. Third term is going to be positive. Our first and last will be perfect squares because they're identical. And this is going to be a double of the product of the 2 terms. Now, you don't need to know that at the moment, but again, when we factor this later, we're going to look at that characteristic, those characteristics. Here we again have conjugates. So I know that my inside and outside will cancel. I'm not going to shortcut and not do the work. I'm still going to show the work and write out the products because it takes 2 seconds to write it out. That's 36v squared minus 30v plus 30v minus 25. My outside and inside do cancel like I was expecting them. We get 36v squared minus 25. And does it have the characteristics? Yeah. 2 terms, subtraction, both perfect squares. 7n times 7n plus 7n times 3 minus 3 times 7n minus 3 times 3. That's 49n squared plus 21n minus 21n minus 9. Inside and outside cancel. 49n squared minus 9. 2 terms, subtraction, both perfect squares. Binomial square again. Write it out. It takes less than 30 seconds to do this problem when you write it out. And I will be exact. I will know that my answer is correct because I took the time to write out the work. Ooh. Almost made a mistake there. Plus 3 times 7k plus 3 times 3. 49k squared plus 21k plus 21k plus 9. Notice we double that. 49k squared plus 42k plus 9. And another one, 5x minus 6, 5x minus 6. 5x times 5x plus 5x times negative 6 minus 6 times 5x minus 6 times negative 6. 25x squared minus 30x minus 30x plus 36. 25x squared minus 60x, that's a big number, plus 36. Notice 5x times negative 6 gives us negative 30x. And then we would just double that. Conjugates with variables in the first and the last. So again, take your time. 7x times 7x plus 7x times 5y minus 5y times 7x minus 5y times 5y. We have lots of variables here, so take your time. 49x squared plus 35xy minus 35xy minus 25y squared. My inside and outside still cancel. Conjugates, doesn't matter if there's variables, one variable, two variables, lots of variables. My outside and inside will always be opposite of each other. 49x squared minus 25y squared. Let's look at those characteristics. Two terms, subtraction, both perfect squares. Yep. 2x times 2x plus 2x times negative y minus y times 2x minus y times negative y. 4x squared minus 2xy minus 2xy plus y squared. Alphabetical order when you have multiple variables. Oh, I made a mistake somewhere. Where did I make a mistake? Where did I make a mistake? So I know I made a mistake. How do I know I made a mistake? Because these did not cancel, and these are conjugates, so I knew that this had to cancel. So I see my mistake. I went back to my work. 2x times 2y, 2x times negative y. I'm not distributing a negative y. I'm distributing a positive y. This should be positive. This should be positive. So that makes positive. This makes negative. And we get that. Now, my middle two terms are opposite. They cancel each other. 4x squared minus y squared. Two terms, subtraction, both perfect squares. So you see that I made a mistake. And we always have to be present in our work when we're doing it. We don't zone out. We don't just get through the problem to finish it. And we don't go through the motions. We're actually engaged with it. We're making sure we're looking and making sure that the work makes sense. So there's a great example of catching a mistake while you're doing it. Binomial squares, I'm going to write out 4x minus 2y times 4x minus 2y. 4x times 4x plus 4x times negative 2y minus 2y times 4x minus 2y times negative 2y. Ooh, lots of space. 16x squared minus 8xy minus 8xy plus 4y squared. So this time, because they're binomial squares, I know that these are going to be doubled. They have to be identical. 16x squared minus 16xy plus 4y squared. Another good one. And this is in standard form. This is where students start putting this y squared up there. First term, first variable, x. First variable, x. First variable, y. So x's first variable in the term is always going to determine its order. So x, and then y. So x's are going to come before this y No matter, just because it's squared doesn't matter. We're going to do x's before y's. Now we tie on our first variable because both are x's. This is an x squared, this is an x. So this stays here, and this is the correct order. Next one, 3x plus 8y times 3x plus 8y. And my voice has put my wife to sleep. It is, so if you're already sleeping also, I get it. 3x times 3x plus 3x times 8y plus 8y times 3x plus 8y times 8y. I'm running out of space. 9x squared plus 24xy plus 24xy plus 64y squared. Now, just because I wrote messy over here, I still looked back up here and made sure that just because my writing still can coincide with that, 9x squared plus 48xy plus 64y squared. Coefficients do not set the order of standard form. Your variables, your leading variable in each of the term does. And that's it. So this is a great opportunity to open up the third trimester with a solid score. So please take the time to review and practice and come in with any questions that you might have. Good luck.